Hey guys, so I know some of you still had a few questions about the RAAS system. So hopefully you all got on to Blackboard and you went and looked at the learning content modules. Like I said, there are some other things in there to help you learn this system, because it is super important to be able to understand, the mechanisms between how these medications work, particularly, your ACEs and your ARBs. So I'm going to go over this again real quickly just to see if this way will help you guys. Feel free to let me know if you just want like a little screenshot of this picture to kind of help you. Again, this is like my own little diversion here. So what happens is, you say you have a patient who is hypotensive, okay? So that means it could be from a fluid volume deficit. So your body recognizes this low blood pressure. It's going to stimulate your body to release renin. So your kidneys is responsible for doing this. So they're going to release the renin into the bloodstream to start circulating. And then it's going to go into the liver, where you have the production of angiotensinogen. So angiotensinogen is what is needed to convert or go into angio 1 and angio 2. Now, remember, these two are the components of what's going to start the mechanism of increasing the blood pressure. So Ang2, so angiotensinogen 2, is the vasoconstrictor part, okay? In order for Ang1 to convert into Ang2, it needs the enzyme ACE, okay? This is released by the lungs. So when this is released into from the lungs into the bloodstream, your body is going to turn Ang1 into Ang2, and it's going to vasoconstrict. So the vessels are going to get really small, okay? So that's going to increase the pressure, okay? Increase the pressure, causing a narrowing of the vessels to increase the blood pressure. So it can do this in two ways. So the body can release what's called antidiuretic hormone, or ADH, and it's going to tell the body to keep the pee in, okay? So we don't want to pee it out, okay? So it works opposite of what diuretics would do, because it's an antidiuretic, okay? So your body is going to hold in that urine and keep it from eliminating, okay? So in return, that's going to increase the blood volume, overall increase blood pressure, okay? Or, as in with your ARBs, so those are your sartans, it can respond and go to the adrenal gland for the adrenal gland to release the hormone aldosterone, okay? Aldosterone works because what it does is it makes you retain sodium, which means you're going to retain the water. So you're going to have that increased volume to kind of make you increase your blood pressure, okay? So aldosterone, again, aldosterone's response is to make you retain the sodium, okay? Water and sodium follow together, okay? Remember, where sodium goes, water flows. So it's going to stay right in there with it, okay? So now when you're thinking about those medicines, so here you have ACEs. So these are your medications that end in "-il", okay? Example, lisinopril, okay? Another one is like enalapril. That's another more commonly used one. And then you have your ARBs. So these are your sartans. So you got to know these, okay? Your two common ones are valsartan, losartan. So if you see a patient taking these medications, it is to lower the blood pressure, okay? These are your antihypertensives. And as you learned from our discussion board, these two medications are what are primarily used in patients that have some kind of renal impairment, just because they are renal friendly. So in order to understand these on how they work on the renin system is literally within what they're cutting out. So this is what I was trying to explain. So your ACEs, angioconverting enzymes, okay? An ACE inhibitor, so think about that. It's going to inhibit the action of ACE. So as we look down here, remember this is the enzyme that is secreted from the lungs to change Ang1 into Ang2. So if we inhibit this process, okay, we're cutting the connection here, the communication between Ang1 and Ang2. It's not going to stimulate that, so which means you're not going to get the vasoconstrictor part, okay? You're going to get a dilation aspect, which means it's going to lower the blood pressure, okay? And it's the same thing with the ARB, okay? Angioreceptor blocker, okay? So angioreceptor blockers, what do? Okay? They're going to block the mechanism of this, okay? So you're not going to have that angio2 vasoconstrictor part, okay? It's going to block, the body's ability to secrete aldosterone, okay? Or the antidiuretic hormone. So therefore, you're not going to retain sodium. You're not going to retain the water. You're going to eliminate it, right? So in the body and out of the potty. That's where it's going. So therefore, you're going to have a return of lower blood pressure. So that's how these medicines work. So again, if the diagram here helps you, by all means, just let me know. Or you can draw it for yourself. I was trying to get a little creative to make it a little bit easier. But again, also think renin-angiotensin aldosterone system. So remember, it does go in a system. So renin, angiotensinogen into Ang1. You're going to release ACE enzyme from the lungs to convert into Ang2. Ang2 is your vasoconstrictor that's going to stimulate your body to either release the antidiuretic hormone, ADH, from the posterior pituitary gland, or aldosterone that's going to be released from the adrenal gland. Again, both mechanisms are to increase the blood pressure by causing constriction or narrowing of the blood vessels, okay? And that's how the mechanism of those medicines work. So if we inhibit something, we're going to prevent it. So again, at that cost, it's at this mechanism right here, and it's going to cut off that communication, okay? Your ARBs are directly going into the main middleman here, okay? They're going to cut all communication from here and block this mechanism from action from working, okay? So I hope that kind of helps. Again, it is, once you just kind of wrap this in your brain, it's super, super easy to remember. The main thing is, again, remember your antidiuretic hormones. Again, those are the I can't pee hormones, okay? They're going to keep the pee in, which is going to increase the volume. Your aldosterone works in the same way, other than just it retains sodium and makes you hold water, because again, sodium and water are best friends. Where sodium goes, water is going to flow. If you have any more questions, just let me know. Like I said, there's plenty of resources on there for you guys to look over. Again, that board that we went over on Tuesday was a great gist of it. Don't forget to look at the other things mentioned and stuff. So if you need any help, just let me know. Again, we'll be at class tomorrow, so you can always just see or ask me then, okay?